This video will be part 1 of lesson 1, solving first degree trig equations. We're going to look at the first two examples under the review. Question A says solve sine of x where it is equal to -1/2. If we were using our cast rule, first thing we always like to do is find out, okay, well, which quadrants is sine negative in? So sine would be negative in quadrants 3 and in quadrants 4. Now there's a few different ways that you can figure out how to do this. Your unit circle is going to crop up a lot in this unit. So if you had your unit circle, remember that sine is always equal to y. So where on our unit circle is sine -1/2? So if you had your unit circle memorized, sine is -1/2 here and here. So these are our solutions. I'm going to show you different ways that we could get these solutions. So one of my solutions, I'll call that x1, is 7 pi over 6. And the other solution I will denote as x2 is going to be 11 pi over 6. How could we find this using our calculator? So remember that if I do the inverse sine of always the absolute value, that will give you your reference angle. So if I bring up the calculator, second sine, always of our reference angle. Make sure that you're in radian mode, so this calculator is set to radian mode. That would be my reference angle. And remember how I showed you, well, what would this be in radians? Divide this answer by pi, and then hit your math one fraction. So my reference angle in radians is pi over 6, or 1 pi over 6. So pi over 6, and that is equal to, I'm going to call it, instead of theta r, xr. So my reference angle is pi over 6. So here would be my reference angle, and this guy is pi over 6. My solution's in quadrant 3. So if this angle is pi over 6, what would the angle in standard position be? And that would be pi plus pi over 6. So x1 is equal to pi plus 6. Convert this 6 over 6, and that's 7 pi over 6, which is what we have down there. The other reference angle is in quadrant 4. So if this is pi over 6, we need to figure out the answer in quadrant 4. So this would be 2 pi minus pi over 6. If I was getting common denominators, this is over 1. So let's make it, if this is over 6, that would be 12 over 6. 12 pi over 6 minus pi over 6 is 11 pi over 6. Okay? And that's what we have there. So there's my x1 and my x2. Question B is where we're actually going to get to solving. So 3 secant x minus 5 is equal to 0. What you want to do is you want to isolate secant. So add 5 to both sides, and we'd have 3 secant x is equal to 5. Get secant by itself. Right now secant is being multiplied by 3. Divide this side by 3 and this side by 3. Secant of x is equal to 5 over 3. We know that secant is a reciprocal trig ratio to cos. So cos of x is equal to 5 over 3. Sorry, cos of x would be the reciprocal of that. So cos of x would be equal to 3 over 5. According to CAST, C-A-S-T, cos is positive. Find which quadrants cos is positive in. So cos is positive in quadrant 1, where all trig ratios are positive, as well as quadrant 4. We need to find what theta is. So we need to find our reference angle and standard position. And this tells us that they want our calculators to be in degree modes. So everybody should take out their calculators, change your mode right now to get into degree mode. And what we are going to calculate is the inverse cos of 3 over 5. Second cos, 3 divided by 5, gives us 53 degrees, and it says to the nearest degree. So I will write down 53 degrees. One of my solutions is right here. So the reference angle is 53 degrees. So 53 degrees is equal to XR. That's our reference angle. So this answer, or this question, has two answers. X1 is equal to 53 degrees. And then my second solution is in quadrant 4. So if I was to put my angle in quadrant 4, 53 degrees, this rotational angle would be 360 degrees minus 53 degrees, which is equal to 307 degrees. And that would, I'll denote as x2, 307 degrees. Okay, what we're going to look at now is how would we write a general solution for solving for these types of equations, and we'll do that on the next page. So to write a general solution, there's two different ways